Good afternoon, Robert Scribbler. It is November 26, 2018. Thank you for joining me for another climate change and clean energy video blog. So for this segment, I am going to provide you with an update on the present global temperature trend as it is recorded by NASA's GISS Earth Monitoring Division. And what we're looking at right now appears to be a very rather innocuous sheet of number data that is updated on a monthly basis by NASA, but this set of information is anything but innocuous. It describes the global long-term warming trend as observed by global temperature monitors and aggregates of global temperature analysis since the 1880s, which at this point shows a warming of the entire Earth system in the range of between 1 and 1.2 degrees Celsius above 1880s averages. Now, this rate of warming that has occurred, 1.2 degrees Celsius might not sound like a lot of warming to a layman or an untrained observer on the issue of climate change, but just to describe to you how sensitive the global system is to what would appear to be relatively mild or moderate changes, the difference between the 19th century and another ice age is 4 degrees Celsius on the side of cooling. So the 1.2 degrees Celsius warming that has occurred in just the last 138 years or so is about 1/3 the distance between the 19th century and the last ice age, but on the side of hot. And this rate of warming is unprecedented in the geological record, at least as far as we can resolve. It is a very high velocity rate of warming. The Earth system is not accustomed to warming at the rate of 0.2 degrees Celsius or 0.15 degrees Celsius to 0.2 degrees Celsius per decade as we presently see warming rates. And it's certainly not accustomed to the more rapid warming rates that would occur if we continue to burn fossil fuels at such high volumes throughout the 21st century. So this NASA record is one of the keystone records of climate change, and at present it appears to be the fact that October of 2018 was the second hottest October in the 138-year climate record, NASA's 138-year climate record, which begins in 1880. With October of 2018 showing 0.99 degrees Celsius, showing a 0.99 degrees Celsius departure from NASA's 20th century baseline, which is a mid-20th century baseline. This baseline average is it incorporates a base period of 1951 to 1980, which is a bit warmer, which is warmer than the start point for the NASA data measure in the 1880s. So if you combine the fact that the NASA baseline period for the middle to latter 20th century is a bit warmer than normal, what you end up with is the fact that October of 2018 was about 1.2 degrees Celsius above 1880s averages, which is a pretty good proxy for a Holocene average temperature. So October was very warm, and I'm going to talk a bit more about why that's the case. Primarily, the reason why October was the second hottest on record is due to the fact that human systems, primarily fossil fuel-based emissions through fossil fuel burning and fossil fuel extraction, have added a massive volume of carbon dioxide into the Earth's atmosphere. In addition, we have a massive volume of methane, which is the number 2 greenhouse gas in terms of radiative forcing coming from both fossil fuel-based infrastructure and poor land management across the surface of the Earth from the human system. And we are starting to see a bit of greenhouse gas feedback from a number of Earth systems, but the strength of the feedback is very small at this point compared to the overall strength of the human emission, about 80% of which comes from fossil fuel burning. Now, looking at the globe for October and taking a snapshot of where it was hot and where it was where it was warm and where it was much warmer than normal, where it was much warmer than baseline temperatures, we see that both polar zones in the northern hemisphere and in the southern hemisphere saw much warmer than normal temperatures. And this is an aspect of human-forced climate change called polar amplification, where the influences of human-caused climate change are stronger in the polar zones. And this is due to the fact that the poles have a number of sensitivities related to the climate system. And so what ends up happening is that as the Earth system warms, the rate of energy transfer tends to move toward the poles. In addition, climate change, human-caused climate change through greenhouse gas forcing preferentially warms the darker regions and the darker periods. So for example, you tend to see greater rates of warming at night than versus the day. And you tend to see greater rates of warming at the poles during periods of polar darkness in the wintertime. And this is the reason for this is the way in which greenhouse gases tend to trap radiation reflecting back from the Earth's surface, the way that greenhouse gases tend to act like a blanket and tend to distribute that heat trapping effect more evenly over the surface of the Earth. And so you get a greater rate of warming versus the warming that you would a greater rate of warming at night versus the difference between warm and cool that you would tend to get between night and day due to the direct influence of solar radiation. And ultimately, if that blanket of greenhouse gases becomes thick enough in an ideal model situation, for example, if you're looking at other planets like Venus, whether it's night or day, eventually, if the greenhouse gas concentrations are high enough, whether it's night or day does not matter. But the Earth system right now is nowhere near a Venus state. But what is happening is you're getting a thicker layer of heat trapping gases, and that preferentially warms the dark periods and the dark locations of the surface of the Earth, namely the poles. Now, there are other feedbacks that occur in places like the Arctic, and the Arctic itself is very sensitive to human-caused climate change, and that's the reason why we're seeing right now the greatest rates of warming occurring in the Arctic. And I'm not going to go fully into why that is for this particular expose, but I just like to point out that polar amplification, the faster warming of the polar regions, is a signature impact of human-caused climate change. And for October, we saw very, very warm temperatures for the northern polar zone in the range of 4 to 8.4 degrees Celsius above normal for a broad region of the Arctic and the near Arctic, namely in the high Arctic and in northern and eastern Siberia, as well as through the Bering and Chukchi Sea region and over Alaska as well. The second warmest region of the world in terms of temperature departures above average. This is temperature departures above normal temperatures. Of course, the poles are still the coldest regions of the world, but because they're warming faster, you're seeing higher anomalies, meaning much warmer than typical temperatures for this time of year. And the second warmest region, of course, was Antarctica in the range of about 2 to 4 to 4.5 degrees Celsius above normal. in the Antarctic zone, in the southern hemisphere, southern latitudinal zone. Now, some other features that I'd like to point out is the fact that the equatorial band is ranging about 1 to 2 degrees Celsius above normal over the Pacific Ocean. And this is a signature of the Pacific Ocean apparently beginning to move into an El Nino state. And an El Nino state is the warm side of natural variability. If we didn't have human-caused climate change, the El Nino periods and the La Nina periods would tend to cycle along an even baseline in which the El Nino periods would be a bit warmer than the baseline globally, and the La Nina periods would be a bit cooler in the form of a sine wave type feature. But because humans are warming the Earth, the overall warming trend is overlaid by the ENSO cycle, the El Nino La Nina cycle, which has a larger influence on the globe. And the El Nino periods tend to push peak global temperatures to new record highs in combination with the greenhouse gas forcing, which has been delivered by decade after decade after decade of human emission. And when you see this signature of El Nino, you tend to want to look at the global temperature records, because that's the point where there's a high likelihood that new global temperature records will tend to be challenged. And it appears that we are entering an El Nino period. It might be a relatively mild or moderate El Nino, but even so, even following a very strong El Nino that occurred in 2015 and 2016, we should still be concerned about breaking new global temperature records, despite the fact that this El Nino doesn't appear to be quite as strong. Now, I'm going to talk about that a little bit more later. So looking at the zonal anomalies, again, we can see the very strong polar amplification or more rapid polar warming signal in the latitudinal zones, with the around 75 to 80 degree north latitude zone showing an average of about 5.5 degrees Celsius above 20th century baseline, NASA's 20th century baseline, and the southern hemisphere pole, the Antarctic, showing about 3.7 degrees Celsius departure above normal in the 80 to 90 degrees south latitudinal zone. It's worth noting that no latitudinal zones except for the near 60 degrees south latitude zone showed cooler than normal temperatures. And looking at the geospatial analysis, you can see this somewhat cooler than normal zone here in the Southern Ocean region in October, as well as a somewhat cooler than normal zone over Canada and a small cooler than normal zone over China. But looking at the spatial distribution of temperature extremes, we can see very clearly that the warmer than normal temperatures are dominant in this NASA graphic, and overall temperatures were much warmer than normal for October, with October now at the second hottest, October of 2018, now at the second hottest on record in the NASA temperature assessment. Now, what's driving at 1.2 degrees Celsius above normal for and that's Holocene norms. So at about 1.2 degrees Celsius above Holocene norms, we are starting to challenge past temperature records, as we saw in the NASA record. And as we see with October being the second hottest on record. And what's helping to drive that is a trend toward El Nino in the equatorial Pacific. Now, what we're looking at here is a weekly ocean heat content evolution in the equatorial Pacific. And the small dotted lines here in this graph, and this is a NOAA graph. NOAA provides an assessment of a weekly report on the state of El Nino and La Nina conditions in the Pacific. And so each small dotted line here is what is called a cool Kelvin wave, and each large dashed line here is what is called a warm Kelvin wave. And a warm Kelvin wave is when you tend to get warm water upwelling from the depths of the Pacific Ocean and transporting from west to east across the Pacific Ocean and rising toward the surface. And as we can see, we've had 1, 2, 3, 4 warm Kelvin waves in succession, and we tend to see these successions of warm Kelvin waves just prior to an El Nino type event. It's worth also noting that the upper ocean heat anomalies have remained in the range of about 0.5 to 1.5 degrees Celsius above normal in the critical zones for El Nino for quite some time, with peak temperatures found during October. And all of these signatures provide an overall trend pointing toward an El Nino event. And according to NOAA, El Nino is expected to form and continue through Northern Hemisphere winter during 2018 through 2019, and NOAA is identifying an 80% chance of an El Nino event occurring. Now, this El Nino event will, as I mentioned before, help to put us in a situation where past temperature records that were set during 2015 and 2016, global warm temperature records, are challenged. It might not push the present 2018-2019 period above the new high marks set during 2016. It could, and that's something that we need to keep an eye on. But very likely we will tend to see temperatures move back toward the 1.2 degrees Celsius and above range as we get into more and more of an El Nino type situation if the predicted El Nino does emerge. And so that's something that we need to keep an eye on, because from a global standpoint, at this point now, every 0.1 degrees Celsius warming is something that we're really going to feel, in my opinion. We are getting into a period in which climate change is becoming more and more dangerous and destructive, and any additional warming will have unfortunate impacts. Now, looking at the Pacific Ocean, this is an Earth null school map, and I'm just looking at this for today, just to give you an idea of present trends looking forward. Not only is the equatorial Pacific ranging from about 2.8 degrees Celsius above average in the central equatorial Pacific, with hot spots off the west coast of South America ranging up to 3.3 degrees Celsius, and a broad, much warmer than normal band of sea surface temperatures in the equatorial Pacific, which is a signature of El Nino. But the Pacific Ocean as a whole is just ridiculously warm, with a hot pool off the east coast of Japan ranging up to about 7.4 degrees Celsius above normal. A kind of hot blob situation appearing off the U.S. West Coast, which has tended to force strong ridge patterns off the U.S. West Coast, which have aided in the extension of extraordinary drought and warmth conditions for the U.S. West Coast, for British Columbia, and for Alaska, and which have also intensified the wildfire regime across the U.S. West, lending intensity to the very extreme wildfires that we have seen recently. In addition, the southern Pacific Ocean is also quite warm, with very little in the way of cooler than normal temperatures, a mild cool pool off the coast of South America in the lower southern latitudes in the range of about 15 degrees south latitude, but with much warmer than normal temperatures in the near 30 degree latitude, south latitude zone off the west coast of South America in the range of 3 degrees Celsius above normal, and much warmer than normal sea surface temperatures off New Zealand, and a concerning warm pool around 1 degree Celsius above normal in the Great Barrier Reef region of Australia. So overall, the Pacific Ocean is much hotter than normal, but also bearing the signature of an El Nino event, which would also tend to push global temperatures toward new records as the regime of human-forced climate change through greenhouse gas emissions, primarily through fossil fuel burning, unfortunately continues to add heat forcing to the Earth atmosphere. And as a final note, I would like to point out that the primary driver for heat forcing in the Earth atmosphere is carbon dioxide, which at present has been increasing by about 2 to 2.2, 2.3 parts per million every year. So for 2019 through spring of 2019, we expect atmospheric CO2 to range as high as 413 to 414 parts per million in the monthly monitors, possibly getting close to 415 parts per million. And these are atmospheric CO2 concentrations that haven't been seen for at least the last 12 million years, possibly the last 15 million years. And so we are getting into contexts where the overall global heat forcing measure is enough, if it maintains long term, to severely warm the Earth's climate in the range of 3 to 4 degrees Celsius, which is much, much more than we have presently seen. And this fact provides urgency to the notion that we really need to get our greenhouse gas emissions under control. We are starting to observe strong impacts, some catastrophic impacts from human-caused climate change, but this is the early, easy stuff that we are seeing at this time. If we keep burning fossil fuels, it just keeps getting worse and worse. And in addition to that fact, even if we just maintain the high levels of atmospheric greenhouse gases that we see long-term warming that has strong impacts. Although if we halted fossil fuel burning or rapidly tamped it down over the next few decades, the overall rate of warming would tend to drop off, and that would help to provide a cushion and provide us some room to maneuver as we learn to draw down carbon from the Earth's atmosphere through better land management and potentially through other techniques. And unfortunately, at this point, because we are so far behind the 8 ball when it comes to human-caused climate change, we need to not only wean ourselves rapidly off of fossil fuel burning, but we also need to learn to manage the human system in such a way that we hit a net negative carbon emission so we can get back to healthier climate states over the long term. So just a snapshot of the NASA GISS report for October, showing that October of 2018 was the second hottest in the NASA climate record. There are some other items of news that I'm going to cover later today or tomorrow, depending on time and research. One of them being the new National Climate Assessment, which was a real doozy. The Trump administration, the climate change denying Trump administration, tried to bury it. And this is a great public disservice to not only everyone living in the US, but everyone living across the globe. This National Climate Assessment is a critical piece of research, and it needs to be heralded across the world because we really need to start working together to not only mitigate and reduce the impacts of human-caused climate change, but to help those who are hurt by it. There is a lot of fear being generated about people who are in need, people seeking help, and there is a big push by right-wing politicians to demonize those people and to drive fear. And this political exploitation of crisis is exactly the wrong response to human-caused climate change. It results in the deterioration of critical institutions that will aid us in response. And part of the necessity of response is to reduce desperation, not to increase it. Increasing desperation increases unrest and increases instability. And we really need to have stable nations and stable governments, globally speaking, to deal with the issue of human-caused climate change. If you can't keep those stable Western democracies in place, then you really get into a situation where it becomes a lot more difficult to respond to human-caused climate change, as we have seen with the rise of an extreme right wing around the globe, which is almost universally a climate change denying and climate change response denying political force. So thank you for joining me, and I'll be chatting with you soon.